Hello everyone. In this chapter, we are going to see about introduction to Cisco Packet Tracer for Internet of Things applications. Normally, the Packet Tracer is an exciting network design simulation tool that allows you to develop your skill set in networking, cybersecurity, and the Internet of Things. It allows you to model complex systems without the need of any dedicated equipment. This is the free software helps you to practice your network configuration and troubleshooting skills via your desktop computer or an Android or your iOS based mobile device. Also, Packet Tracer is available for both the Linux and Windows desktop environment. Next, this is the agenda of today's talk. First one is introduction to Cisco Packet Tracer software and IoT world, and second one is overview of IoT devices and components present in a newer version, that is Packet Tracer 7 version. And next one, there are programming method using this Packet Tracer, both microcontroller unit, that is MCU based devices, and also single board computer SBC. There are two main microprocessor and microcontroller devices are available here, MCU based devices and a single board computer device available here. By using the languages, there are three types of languages we are going to use here. First one is Python, second one JavaScript, third one is then visual objects. Another name is called as blockly objectives. And next one, by using this Packet Tracer, automate a webcam through motion detector sensor using set condition rule method. Here no need of any programming language to implement. Here some set condition rule method we are going to implement. The next, design and implementation of IoT based smart home network. In this smart home network we are incorporate more number of applications like smart power meter and smart monitoring, remote monitoring, etc. Then next one, artificial intelligence enabled IoT based healthcare monitoring system. Here we can monitor the patient conditions remotely. Then next one, AI enabled IoT based environmental monitoring and control. Here we can see the environmental global wise. We can monitor the environmental control, environmental. So, for example, temperature, what is the wind speed, what is the humidity, and all things you can monitor and see, control the environment by using this one. Next one, this slide shows the introduction to Cisco Packet Tracer software. Here, this is a exciting network design simulation tool, and also used for not only with networking, cybersecurity, and Internet of Things. And also it allows you to model complex systems without the need of the dedicated equipment. It is available not only with the computer, also you can able to perform mobile device. It may be Android or it may be iOS. Also the both platform, it supports both platforms, Linux and Windows based platforms. Here the easy way to using Packet Tracer to design the networks varying size without expensive lab equipment. We can no need of expensive lab equipment for testing the applications. How you get the Cisco Packet Tracer software? To obtain and install your copy of Cisco Packet Tracer, there are simple steps are there. First, you go log in to your Cisco Network Academy. Here one page is available. Here I am learning page. There you select resources from the menu in the upper right portion of your screen, and then you can, there are a lot of versions are available. Here select download Packet Tracer, then you choose the version, what version you require. For example, you select Packet Tracer 7 means it available here. It supports Internet of Things, not only with networking. And then save the file to your computer and launch the Packet Tracer install program. And after installation, close and restart your web browser. Then launch Cisco Packet Tracer by selecting the appropriate icon. Then when prompted, use your NetAccount login information to authenticate. And then Packet Tracer will launch and you are ready to explore its features. Here when you open the packet tracer, one user interface menu will open. There are the main menu will appear. The packet tracer is a tool that allows you to simulate real networks. It provides three menus that allow you to. First one is add devices and connect them via cable or wireless, and then one more option is there: select, delete, inspect, label, and group components within your network. Last one, manage. You can manage and control your networks. This is a overview of Cisco Packet Tracer software. Here there are 10 menus are there. When you open the Packet Tracer, by default you will be presented with the following interfaces. This initial interface contains 10 components. First one is menu bar. In this bar provides file, edit option, view, tools, extension, help. Menus are there. You will find the basic commands such as open and save, print, and settings in this menu bar. Then second one is a main toolbar. This main toolbar, the second one. This bar provides shortcut icons to the file and file, edit commands also there. This bar also provide buttons for copy, paste, and redo, undo, and drawing palette and the custom devices display. Then third toolbar, there is a common toolbar. In this toolbar provides access to the commonly used workspace tools like this, select, move layout, and place, resize shape, and add some simple PDU, that is protocol data unit PDU, and add complex PDU. This is first one is normal PDU, then second one is a complex PDU, then fourth one is the logical and physical workspace navigation bar. You can toggle between here logical and physical. Here you can toggle between the physical workspace and the logical workspace with the tabs on this bar. In logic workspace, this bar allows you to go back to previous level in a cluster. To create a new cluster, more objects, set tiled. You can set the tiled background and viewpoint. Here in the physical workspace, there are two workspaces: logical workspace and physical workspace. In physical workspace, this bar allows you to navigate through physical locations and create a new city and create a new buildings and apply a grid to the background. Then is next one is a fifth one is a workspace. This area is where you will create your network and watch a simulation and view many kind of informations and statistics here. And next one is a sixth bar, the real time mode and simulation bar, real time and simulation bar. Here also you can toggle between real time mode and simulation mode with the tabs on this bar. This bar also provides buttons to power cycle. Here power cycle devices and the fast forward time, as well as play control button and the event list. This is a toggle button in simulation mode. Also it contains a clock that displays the relevant time in real mode and the simulation mode. And the next one is a network components box. This one network component box. This box where you choose the devices and the device specific selection box. This is where you choose that. This one it will appear. There is a searchable field also there. Here there is a searchable field that in these fields you allow you to enter a device name to look for the specific device quickly. Device name shows when you mouse over the device icon in the device selection box here. In the next one, ninth bar, device specification box. This box contains the types of devices and the connection available in Packet Tracer. Here this box is where you choose specifically which devices you want to put in your network and which connection to make. Then last one is a user created window. The 10th one is a user created window. This window manages the packets you put into the network during simulation scenarios. Here we are seeing the slide overview of IoT devices and components are there. Here new IoT devices available in this version. Here nowadays we are calling Internet of Everything, that is IoE. IoE contains IoE is actuators and sensors and smart devices. These are the IoE means items that cause or show a reaction to stimulus or the environment is called IOE. Then this Internet of Everything contains three parts there. First one is a machine to machine connection, and second one is a machine to person connection, and third one is a person to person connection. Here machine to machines mean there is M to M. Here data sent and received from one machine to another machine is called IoT. Here machine to person, second one is machine to person. Here the data sent or received from a machine to a person is called M2P, often is called as data and analytics. Here the third one is a P2P, that is a person to person. Here data sent and received from one person to another, so often is called as collaboration. Here the IoT actuators. What is IoT actuators means? That items that causes or shows a reaction is called IoT actuators. Then next one is IoT sensors. These are the IoT sensor. The items that sense a reaction to a stimulus or the environment is called as IoE sensors. Then the smart devices that can be connected to sensors or actuators. These are the some basic components, IoT components or devices available in newer version Packet Tracer 7. Here there is some introduction about Internet of Things IoT world. Here normally Web 2.0. So Web 2.0 is nothing but the Internet is now widely used for plenty of services, that is information retrieval, video streaming, file sharing, online shopping, banking and social networking, etc. It is known as Web 2.0. Okay, now what is Web 3.0? This Web 3.0 but Internet continues in evolution and will be enable objects to connect to each other, to get some more information, to take some action or to share information. This new world of connected devices is called Internet of Things and will form the new Internet named Web 3.0. Some IoT applications domains, list of some IoT application domains are there. Here smart city. In this smart city application, here you can monitor the structural and environmental monitoring, vehicle traffic monitoring and smart street lighting system. And also the concept of a smart city is one of the most mentioned and agreed to by many people in the IoT world. There are various domains as there, such as the car and traffic monitoring management, the city environment control, especially in the smart city application, IoT application. Then vehicle traffic monitoring is the main important one. Vehicle traffic monitoring is the main important one, where sensors on the roads can allow to detect traffic jam, polluted roads or damaged roadways, and dynamically propose rerouting for end users having a GPS like equipment and able to receive such informations. Then smart street light systems. Here smart street light which can be equipped with sensors for detecting cars or human movements, and which can then dynamically be turned on when there is some activity in the zone and turned off otherwise. It can help to save energy and money for the city. Okay, right. And also some other sensors for detecting abnormal pollution in some places or water level or fire in this case. The early detection of abnormal environmental situations could be used to alert the peoples. You can also imagine to have sensors for the trash bins for public toilets or detecting the dirty places and they inform the appropriate service to take the right actions. That is clean the toilet or empty the bins like bins, etc. And also here structural monitoring. Here are the roadways smooth, is the bridge is safe, sensor built into the infrastructure can alert the alert of potential issues and automate the maintenance. And also it supports the autonomous or self-driving vehicles. This is happening to some extent with some forming of public transformations and dedicated right of way. But IoT enables laying sensors on common roads for assistance with autonomous vehicles for public transportation and delivery, carpooling and shared transportation, etc. And the next one is the smart home. Here a smart home is a typical smart home architecture, divides the communication network into multiple components. Here multiple components, yeah, home network with the distributed sensors throughout the home. Here one gateway, a gateway which collects the information from the sensor, and we are cloud based hosted platform that receives the information from the gateway to store and analyze. And the mobile devices of the home occupants who can connect to the gateway or cloud server to receive the information and notification about the home while away. This architecture allows a incremental deployment of new technologies and protocols for the network embedded within the home, as it is separated by the gateway from the wider global internet. Here the important one is the gateway. The gateway can act as a translator between a new protocol, say CCN, that is a content-centric networking protocol, and the existing infrastructure. Among the various services, we can be part of the smart home use care. We can identify some connected home appliances and home video monitoring. Connected home appliances means such as fridges, refrigerator, which can order new food products or beverages when it defects that a lower threshold has been reached. Then home video monitoring. The home can be equipped with a small cameras located in several locations in the house, which can stream the video to the owner of house owner for a remote monitoring, and can send alarms when detection of some movement in the monitored area or abnormal behavior, smoke, carbon monoxide, is a fire, etc. Then remote automation also there. Remote automation, nothing but where the devices can be remotely controlled to make some actions. For example, to close the shutters and doors, to turn on and off the light, TV or PC, etc. Then energy management is also there here coming. To set the temperature and light in a room as a function of the number of people in the room, the time of a day, the external conditions, the cost of the utility. Then remote monitoring also, the remote metering also we can do with this smart home. Here remote metering means where the gas or electric meter can be read or can be upgraded in case of software update for specific action, etc. This list not exhausted, but aims at providing a good overview of what smart home can be. It shows that in the next years, many home appliances can be connected and automated, and IoT protocols in this case will be used to connect them to the internet. And this is a vehicle monitoring system and vehicle automatic applications, and nowadays we can say sensors for environment detection and monitoring. Here also some methods are there. Here healthcare nowadays in this IoT world deal with healthcare, telemedicine and wearable applications. That healthcare is a domain investigated by many people, especially with the exploding cost of managing healthcare for the baby boom generation. And then we can also imagine sensor which can remind the people to take their medication, or even to suggest to increase or reduce their prescribed quantities according to the current value of some monitored metrics, example glucose levels for diabetics, blood sugar levels, etc. Here we will then have several sensors deployed in clothes, watches, wearable accessories, even jewels, in order to continuously monitor the blood pressure, heartbeat, blood glucose level, blood oxygen levels, and etc. These are there are coming wearable applications, and telemedicine also there. In this telemedicine method, their health needs to be monitored, and sensors should be able to detect abnormal values very soon and alert responsible peoples, for example doctors or hospital and family. Here the overview of some IoT components and boards in Cisco Packet Tracer 7 version. Here MCU board is nothing but microcontroller unit. Like Arduino nowadays, Arduino is famous one. But like Arduino, MCU board, that is a MCU board is a microcontroller unit. By using this, we can able to write the program Python, JavaScript, and visual objects. Here, this is a MCU board in my Cisco Packet Tracer software. There's here PT, IoT, and NM 1W model is a wireless model. This is a wireless model, provides 2.4 gigahertz wireless interface suitable for connection to wireless networks or home gateway. Here, when you double click on MCU, we can get this type of tab menu. Here, there are some options are available here. There is specification tab and physical tab and configuration tab and programming and attributes tabs are available here. In the specification tab, here what is the method, what is the specification of the MCU board, and the next one is a physical. Now we are seeing the physical view of microcontroller unit. Here the specification describes the features, usage, local and remote control of the device. Here physical available models and power connections. Here available models and power connections are there. Here config means some shows the display's name and serial number, network configuration, and all things. Here attributes nothing but it displays the device attributes such as MTBF. MTBF nothing but the mean time between failure, power consumptions, and cost also there. Next, these are next one. Here we have the SPC board. SPC board is another form of microcontroller board. Here SPC means single board computer board. This is single board computer like Raspberry Pi. Nowadays we are using Raspberry Pi. It supports 3 types of programming language such as Python, JavaScript, and visual objects. Here also, when you click on SPC, that is a program. This is a programming view of SPC board. Here there are a lot of options are available here, like MCU. Here one more option is available for programming. Here, what is the difference between this MCU and SPC? Here SPC having that programming, MCU also having programming. Here the advanced type, that is especially for Python, JavaScript, and the visual objects programs. Here also specifications, physical configuration, and desktop programming attributes menus are there. And then home gateway. This is an important device in IoT Internet of Things. This one, when you this is available from click the wireless devices icon here. This one, first one. This is first you click this one. Here already we mentioned about this in the left corner. Here what are the device selection boxes available here. This is a specific device type box is there. When you click here, you will get this this menu, this tab. Here this is the wireless tabs. Click the wireless devices icon in the device selection box and click home gateway. Drag and drop to your workspace. Click the home gateway device icon and then click into the logic workspace to add the device. Here what is home gateway? This is a symbol for, this is a icon for home gateway. This home gateway acts as a local connection to your IoT smart devices and to provide internet access and wireless connectivity and local logic for smart devices. This device provides an IoT registration service that always turned on, and auto discovery service for the things in the local length Ethernet or wireless networks. Once you connected the home gateway, the user can control and monitor devices from their smartphones and tablets or PC. You can see the control and monitor devices by using our own smartphones or tablet or our PC. Then this is a view of configuration view of home gateway. When you click on home gateway, you will get the dialog window here. Here also the 4 subtabs are there: physical, configuration, and GUI and attributes. Here These are physical means available models and powers here. Once you click physical means here available models and powers are there. Here in config tab shows the display's name. What is the display name? This display name and interfaces. It may be LAN or wireless. This interface. It may be LAN or wireless, and to be configured with this one. This is a GUI. Next one is a GUI. Shows the services to be turned off. What are services to be turned off here? Is nothing but graphical user interface like. Then attributes. In these attributes showing the features and values related to their devices, etc. Then next one is IoT registration server. This is available from here. This is place the server. This is end devices. This is called end devices. Then previous one home gateway available from this one. Now you click on end devices icon. You will get this bar. You will get this one. Then choose the find the server and the devices selection box and drag and drop to your desktop. So IoT registration driver module. This one. This is also a wireless module. This is here like home gateway also available in Ethernet connection with and wireless connection also there. Wireless model option also there. You can select which models you required. Here also IoT registration server by using you can connect via Ethernet cable or wireless connection. You can able to connect this one. Here IoT registration server. Is also the model name. This is a PT host NM1 is a wireless model. This wireless interface suitable for connection to wireless network also. This model supports protocols that use Ethernet for LAN access. Here also some tabs are available here. Physical tab, configuration, services tab, and desktop and programming and attributes tabs also there. Next one, what is the IoT registration server? How to enable the registration server? Normally the server option, you have to enable the option called registration server. Then only it will work as IoT. You see this services view. When you click on server, there are some tabs are available. Here you click the server. So double click the server. Go to service configuration window. Then click the services tab. In the services tab, you click the IoT service. There are a lot of services available here. For IoT application, you choose IoT. Then you click this registration server button. This should be on. Then in configuration tab also in the global setting. Here global settings are there. This is a configuration tab. How to configure the registration service on the server. Click on the configuration tab here. Configuration tab in global settings. In the here settings are the global settings are there. Global settings window. Change the display name. Here display name you type the display name as registration server. Then server and change the DHCP and DNS IPv version 4 setting from the default static to DHCP. Here there are two more options are available here. One is static method, another one is a dynamic host configuration protocol. Normally you select for wireless device, you choose DHCP. And then IoT registration server, click on the monitor. Here how to monitor and control the connected devices. It may be wireless or it may be wired. Here click the IoT monitor icon. Here you click a desktop. In this desktop you will get lot of options are available. In particular in this option you choose IoT monitor. You open your IoT monitor icon here. If you click on IoT monitor, here in this window will coming. Here you have to type the server address, server IP address. You can create username and password also there. This is a IoT monitor view of registration server. Then overview of some IoT components and actuators and sensor. Already we discussed about these actuators and sensors. Actuators is a causes or shows a reaction. For example, what are the example for actuators? LCD, LED, speaker and alarm, etc. These are all the some actuators. And then next one, sensors. That is a sensor is nothing but it sends the reaction to stimulus or environment. What is a example for sensors? Some environmental sensor, flux sensor, water sensor, and wind sensor. There are a lot of sensors available in Packet Tracer.